Ever wondered why you don't feel like you're zipping through space? Our planet is spinning at a staggering 1,670 kilometers per hour at the equator, faster than a jet plane. Imagine standing on the equator. The ground beneath you is moving at breakneck speed, yet you feel nothing. For perspective, a fast car goes 120 kilometers per h, a jet about 900 kilometers per h. Earth's spin? Nearly double that jet. But we don't feel wind rushing past, or our hair flying. Why? The answer lies in the size of Earth and some amazing science. Earth's massive circumference, over 40,000 kilometers, means everything on its surface moves together, completing a full spin every 24 hours. This spin gives us day and night, setting the rhythm of life for billions of years. So if we're moving so fast, why does everything feel still? Why aren't we flung into space? The secret, a smooth ride and a powerful, invisible force keeping us grounded. Let's dive into the science behind our peaceful, high-speed journey. The key to this mystery is constant speed. Earth spins smoothly, never jerking or jolting. Imagine riding in a car on a perfectly flat road. You barely notice you're moving unless the car speeds up or slows down. Everything on Earth, your house, the trees, even the air, moves together at the same speed. That's why your distance to your TV or your friend never changes, even as you all hurtle through space. This is called a frame of reference. From our perspective, the ground isn't moving because we're moving with it. You only notice motion when something moves differently within your frame, like a bird flying or a car driving by. Even the atmosphere spins with us, held by gravity, so we don't feel hurricane force winds. If the air didn't move with Earth, we'd be blasted by unimaginable winds. Luckily, our atmosphere is a loyal travel companion, spinning right along with us. That's why our high-speed journey feels perfectly calm. So, why aren't we flung into space by Earth's spin? The answer? Gravity. Gravity is a powerful force pulling everything toward Earth's center, much stronger than the weak outward push from spinning, called centrifugal force. At the equator, gravity's pull is about 300 times stronger than the spin's outward force. That's why, when you jump, you always come back down. Fun fact, you actually weigh a tiny bit less at the equator than at the poles, thanks to that small centrifugal force. But the difference is so small you'd never notice without a super-sensitive scale. Gravity is the ultimate anchor, keeping us, the oceans, and the atmosphere firmly on Earth. It's the force that keeps the moon orbiting us and us orbiting the sun. Without gravity, life and our smooth ride wouldn't exist. To understand why we don't feel Earth's motion, think of riding a high-speed train. Once the train is moving smoothly, you can walk, pour water, or toss a ball as if you're standing still, because everything inside is moving together. You only feel motion when the train speeds up, slows down, or turns, when there's acceleration. Earth's rotation is even smoother. No jerks, no sudden stops, just a constant, graceful spin. It's like being on a giant airplane. You're moving fast relative to the ground, but not to your seatmate. This is inertia. Objects in motion stay in motion unless acted on by another force. We were born into this motion, so it feels like rest, our normal. That's why Earth's spin is invisible to our senses. Here's a cool fact. Earth's spin is slowing down by just 1.7 milliseconds per century, thanks to the moon's pull and ocean tides. Millions of years ago, days were shorter, but the change is too tiny for us to notice. Earth's spin also affects weather and the path of projectiles, a phenomenon called the Coriolis effect. In the northern hemisphere, it makes hurricanes spin counterclockwise. In the southern, clockwise. So even if we can't feel the spin, we see its effects all around us. Next time you look at the sky, remember, you're on a giant sphere spinning faster than a bullet, orbiting the sun at 107,000 kilometers per h. Gravity and constant motion make this wild ride feel perfectly still. Our planet's silent, high-speed spin is one of the universe's greatest hidden marvels.